Hello and welcome to another section in further maths. Today we'll be talking about resolution of forces. And when we talk about resolution, means compressing forces into horizontal and the vertical component. That's all what resolution of forces is all about. For example, when we talk of resolution of forces, we say a given force can be resolved into two parts and each part is called the resolute. A given force can be resolved into two directions but which are perpendicular to each other. The component along the y-axis is called the vertical component. So the vertical component is the component, while the component along the s-axis is called the horizontal component. And in resolving the vertical component, we use the force sine theta. While we want to resolve the horizontal component, we use a force cos theta. So that is how it's been done when it comes to resolution of forces. Now after that, we generate our resultant, which happens to be the force that acts as a unique component of the two forces. For example, three forces. Now these are the three forces. 60 degrees. Let's create our force. We have to create our force. We have this at this point. We have this at this point. And we have this on the straight line because they say this one is 180 degrees. So this is 4.5. 180 degree. And this is the force here is 2 Newton. 2 Newton, and its angle is 60 degrees. While this other one is 30 degrees, and the magnitude of the force is 5 Newton. So we want to resolve these forces into vertical and horizontal components. So let's create a table for that. Horizontal and vertical component. These are the two components that we need to resolve this force into. So we divide it. Now, in creating the vertical and the horizontal component of the forces, we start with the horizontal component. Just like what I say, for force P1 is equal to, now what is the force for P1? Here is 2 Newton. You call it 2 sine 60, which is equal to 1.731. It's equal to 1.7321. Now, in this other side, P1 will now be 2 cos 60, which is equal to 1, because the value of cos 60 is half times 2 is 1. Now, we are resolving P2 to equal to, now these are second force. Let's call this P2. Let's call this P1 and let's call this our P3. We are trying to resolve them. Now, in resolving our P2, we now say is equal to 5 cos 30, which is equal to minus 4.33. And if you're resolving this component, is 5 sine 30. 5 sine 30, which is equal to 2.5. So we have to do, okay, these are P3 and these are P2. These are P2, we take from this direction. So for P3, we now have 4.5 cos 90, because it's located at this point. So it's 4.5 cos 90, which is equal to 0, and 4.5 sine 90. But in this vertical axis, you resolve into the negative component, which is equal to minus 4.5. So with this, let's add and get our result. So with this, we have this to be minus 2.598, and we have this to be minus this plus this one, okay, which is equal to minus 1. So this we've resolved this into two different components. So that's to say, we want to have our force. We have a force of this nature. Let's say we are resolving into this. So the horizontal component is minus 2.598, and the vertical component we have minus 1. This is our value. We've just resolved it into this format, but we have to get the value for our resultant. Let's do it. Resultant r square is equal to minus 2.598 square plus, that's minus 1 all squared, which is equal to 6.7496 plus 1. So r square is equals, if you add this, it gives you 7.7496. So therefore our value of r is a square root of 7.7496, which is equal to 2.789. Now the resultant here is 2.789. Why that of because now if you want to draw it, let me show you something. You can see that this force lies in the negative axis. This other one lies in the negative axis. So both x and y are negative. So if you want to draw it, your diagram will be of this nature. You bring it down because they are both negative to be of this nature. So this is your minus 2.598, and this point is your minus 1 because the minus axis, while this point is your r resultant, and this happens to be the magnitude of force between them. So this will be the nature of the diagram. So I would like to say thank you for being part of today's lesson. Do well to take the test that will appear shortly on your screen, and we'll be looking forward to seeing you in our next lesson. Thank you.